Okay, question 3. The best thing to do with these riddle-like questions is have a go at it, but it is only a 3-mark question, and I can tell you now this one isn't very nice, and you would be better off using your time in the exam on the other questions first and coming back to this one. The mark scheme recommends you do this by trial and improvement, but I found that just as complicated as working it out with a bit of algebra. So I'm going to show you with a bit of algebra, but basically this is a riddle style question, and some of these questions have come up over the last few years, and all I can suggest is you don't take more than 5 minutes max looking at this. So a shop has 31 plant pots. We're told that some of the plant pots are blue, some are yellow and some are red. And then underneath here we have that 5 more blue pots than yellow. 5 more mathematically is a +5 situation. And then we're told that there are 4 times as many blue pots as red. 4 times as many is a multiplying by 4. So reading that language, already I'm thinking of 5 more being +5 and 4 times as many as being multiplying by 4. I would recommend that you focus on one colour, and I'm going to focus on red, because I can use the red to link me back to the blue, and I can use the blue to link me then to the yellow. I can't link the red to the yellow directly, but I can if I think of them step by step. So the first thing that I know is that for blue, there are 4 times as many as the red. So B equals 4R. And then if I go to line up, I can see that the blue is also going to be the yellow plus that extra 5. Add an extra 5. So if you look at this now, you can see that this number of blue is the same as this number of blue. So the 4R number is the same as the y plus 5 number. And the 4R number, if we took away 5, would just be the yellow number. I know, bear with me. So if I think that I know I have blue plus yellow plus red, and that's worth a total of 31 plant pots, and the blue can be written in as 4R from this bit by here, and the yellow can be written in as 4R take away 5 from this bit by here. And obviously the red can be written in as red. That's what it is. Then now I've got the same total of 31 plant pots, but I'm only talking about a combination of red ones. I have 9 red ones. Take away 5 is worth 31. So 9 red ones, when I add on 5, is worth 36, which means when I divide by 9, the red ones must be worth 4. Now I have seen students try different numbers to try and solve the question themselves and stumbled across the 4. Absolutely acceptable. If you can do that in 3 minutes, go for that. If red is 4, then the blue must be 4 times as many as the red. That would be 16. And if the blue is 16, then the yellow is going to be that 16, but without the extra 5. So it would be 11. And they come to a total of 31. Question 4. They only want the next 2 numbers in the pattern. We can put them here. They don't want anything like the nth term. So I can see that these are dropping by 7, dropping by 7, dropping by 7. I predict that's going to continue. And 5 and minus 2. A 2-mark question that takes far less time than the one above. To simplify these, I've got to concentrate on the signs as well as the letters. So that minus sign belongs to that 3G. And I must remember that because this minus 5 belongs to the F's, with that plus 3. So if I colour coordinate them, I can see that I've got 10G and I need to take away 3G. So I have 7G over here for my answer. Likewise, I've got a minus 5F to add to a 3F. And on a number line, please think about this. On a number line, we're going to have to start on minus 5 over here. And when we add on 3, we will move up 3 units. So to minus 4, minus 3, minus 2. So I have minus 2F for the F section. Part C, this time I'm finding the value of K, which is inside a formula. So this is a little trickier. The T value is 11. So this part here would be 2 11s. The M value is 4, so 4, and then 3K is the bit I'm trying to find out. So 22 equals 4 plus 3K. Take off the 4, 18 is worth 3K, so divide by 3, and the K must be worth a 6. Double check. Put the 6 in up here to have a look. So does 4 plus 3 6s give me 22? And the answer is yes. Question 5. There are 3 red cards with 3, 6 and 9. There are 4 green cards with 1, 2, 3 and 4. The writing underneath then tells us that the player's score is the sum of the 2 cards, and sum means add. So they filled in most of the table to find all the different possible answers, and you can see just 6 little spaces to fill in for 1 mark. So they did here 1 plus 3 to make that 4, and I'm going to just do in the box above 1 plus the 6 to give me 7, 1 plus the 9, 3 plus the 6, 3 plus the 9, 4 plus the 6, and then 4 plus the 9. I have to now look at probability of getting more than 9. To get a probability of being more than 9, 9 is not allowed, so that's 10, 11, 12 or 13. 9's not allowed though. So I can have that 10, that 11, that 12, that 13, that 10. Out of the 12 different answers in the table, 5 of them are okay. So Sophia plays the game once. What's the probability that she wins? More than 9. 5 out of 12 is the chance of her winning. 60 people play the game. So I have to do 5/12 of 60. So I need to divide it by 12 and then multiply that by 5. 60 divided by 12 is 5. So I expect there to be 25 winners. I expect there to be 25 winners of this game. Question 6. In this question, it's an OCW question, so I need to be organised. I need to make sure I've used my units, my formulas. If I use one, write it down, and I must make sure I label each of my calculations. I have a right angle triangle joined to a rectangle, and they tell me that the area of this rectangle is 45. To work out the area of a rectangle, you need to do the length times width. So they have got an answer of 45 by doing that 9 multiplied by something. So I think that something is going to be a 5. Because 9 times 5 is 45. So I think that the width of this rectangle is 45. And I can see there across the top that 15 goes to the very end of the triangle, and obviously I know that if I stop here it'd only be 9, This tells me that the bottom of the triangle must be 6 centimetres, and the area of a triangle is half times the base times the height. So half times the base times the height, half of 30 is 15. Okay, if I do all that, that gives me just the 5 marks. That doesn't give me the full 7 marks because of the way I've written it down. So to write it down and get those extra 2 marks, it looked like this. Area of rectangle equals length times width. So for rectangle ABDE equals 9 times dB equals 45 centimetres squared. That's told out at the top. So dB, the side I was interested in, would be the 45 divided by 9, which equals 5 centimetres. Including the units, including the formula, and labelling my calculations so that the examiner knows I was finding dB. And then for the length of DC, the highlighted lines across the top. So DC equals EC, which was the full length of 15, take away ED, which was the length of 9. So 15 take away 9 equals 6 centimetres. Sorry, I've got to include workings out and label all my workings out for every part of my calculation. So that explains where the 6 centimetres came from. And then for the last part, area of triangle equals half base times height. Triangle BCD equals half times 6 times 5 equals 15 centimetres squared. That answer, same 15, but that answer would give me all 7 marks. Okay, question 7 is 3 solving equation questions. If I can see a divide by 5, I will times by 5, and the W will be 50. If I can see a divide by x, I will multiply by x. 42 will equal 7x, and then I'll divide by 7. 42 divided by 7 is 6. In this question, when you're dividing by x, they swap locations so that you can then get an answer. 42 divided by 7 gives you the answer of 6. And in part C, it's a 3-step question. First of all, I take away 9y because it's the smallest number of y's that I have. The left-hand side becomes a 4y, take away 5. The right-hand side becomes 27. Then I deal with the minus 5 by adding 5 to both sides. 4y is now on its own. The total on the right-hand side is now on 32. And then I divide by 4 because of the multiplying 4, and I get the y was with 8. Question 8. Question 8, I need to deal with some odd or even numbers. So my odd numbers are my 1, 3, 5, 7. My even numbers are my 2, 4, 6, 8 and 10. And if you can show something works for 1 or 2 small calculations, then that will hold for all numbers, odd and even, and the relationships between them. So if I add an even and an odd number, the example that I would use would probably be a 2 plus a 3. That makes 5, telling me that they're all going to be odd. An odd number plus another odd number That makes 8, telling me that they're going to come out even. An even multiplied by an even. Looking at my answer, even again. An even multiplied by an odd. Even again. And the last one, an odd multiplied by an odd. Odd. So I've just done a calculation, and every time I've just looked at that one calculation to make my decision. I could have done 2. I would have seen that I would still have had the odd or even as predicted, but I've done the calculation close to the question so that I can see exactly which one's which. Question 9. Write down 5 numbers that satisfy the following. They've got to be between 1 and 9. They must have a median of 6, a range of 7, and a mean of 4. Now, these 4 bullet points all have to be satisfied, but to get some of those 3 marks, you can just make sure that the numbers you use are working for 2 of the bullet points. Doesn't have to be all 4. The more bullet points you can actually make sure you cover, the more of the 3 marks you're going to get. So I can make sure I've got 1 mark by only using numbers that are between 1 and 9. To make it even better, I know that the median is 6, so I'm going to put that 6 in the middle straight away. If the range of the numbers is 7, let me just write down the median as the middle there. If I want the range of numbers to be 7, that must be the biggest number, take away the smallest number. So it's not 9 at the top and 1 at the bottom, because that would be a range of 8. So I'm going to say it's 9 at the top and 2 at the bottom, because that will give me the range of 7. And I've now worked with all 3 bullet points. The mean is 5. Now the mean is the total divided by how many. And this time there's 5 of them, so it's the total divided by 5. If the mean is 5, this is the one that's going to solve this now. If the mean is 5, the total must have been 25, because that's the only way 25 divided by 5 can give you a mean of 5 as an answer. So these numbers must add up to 25. 2 plus 6 plus 9 plus the 2 missing numbers must come to a total of 25. Well, so far I've got 17. So 17 plus those 2 numbers makes 25. Those 2 missing numbers must come to a total of 8. If those 2 numbers must come to a total of 8, I first of all thought that I must have 3 and 5. But 3 and 5 can't be placed one either side of a 6. The median wouldn't be 6 if you put 3 and 5 there, because 6 wouldn't actually be in the middle. So another way of getting a total of 8 is to have another 2 and another 6. The mean of 5 still works, and so does all of the others. Question 10. A regular polygon has an exterior angle of 45 degrees. Exterior angles always add up to a total of 360, because it's always the equivalent of going around the outside of a shape. A square, rectangle, circle, when you go around the outside, you've always done a full 360. So if we've got 45-degree turns, if I knew how many 45 degrees I needed to make 360, I'd know how many corners that we have. And that's going to be 8. So it's got 8 sides. So it's an octagon. Unfortunately, I can't do part B on the iPad. I'd need to show you with a compass and a ruler. So for that one, we're going to put down there that you need to see a teacher. Thank you. Bye.